In this video, we'll demonstrate the software that we have developed for automated road pavement condition. I will start with some of the basics and then we'll move on with the software that we have developed. So in this software, the idea is that an camera is installed on the front of the dashboard that you can see in this red box. And along with that, we have a GPS and a distance measuring instrument that is installed in this video van that is recording the distance and the location of the van. And this is the frontal view that is being captured when the van is moving on the local and regional roads in Ireland. So we are using an RGB camera. So the idea is the position of the road is being captured by the GPS with an onboard computer along with the distance measuring unit, and the images are captured from the RGB camera. And using this RGB camera images, we will determine the pavement ratings, and then this pavement ratings would be assigned to each image. So this is the view that we will see from the camera. This is the full view, while in our software, we will be using the cropped image that would be passed on to our AI algorithm. So the rating of the pavement would be on a scale of 1 to 10, as you can see here. So 10 and 9 corresponds to no visual defects. 9 would be minor defects. And both these rating would be regarded as green, while 7 and 8 are usually in the range where you can see moderate defects such as raveling and bleeding, and they are color coded as blue. 5 and 6 are color coded as orange, and they have a moderate pavement defects. 4, 3, 2, and 1 are categorized as red color band, and they have structural distresses that includes rutting, alligator cracking, poor patching, and so on. 1 is the distress rating of the pavement, where the road pavement is totally disintegrated. So these visual pavement condition rating is done in Ireland for all the local and regional roads. So this is a broad flow of the algorithm. The image that we have captured along with the GPS and the distance readings are being given to the AI algorithm, which calculates or which extract the pavement of the in the image, and then this extracted pavement is given to the AI algorithm that we have developed to classify on a rating scale of 1 to 10. So this is the deep learning framework that we have developed. The training stage, in the training stage, we have developed our algorithm for the segmentation of the pavement pixels based on a deep learning architecture. And similarly, we have also developed a model for classification of the images on a rating scale of 1 to 10 that basically classifies that first extract the pavement based on this first deep learning model, and then use that pavement pixels, extracted pavement pixels to to classify them on a rating scale of 1 to 10. and then the output can be used to can be used for assigning a condition index to an image. Now if we move on to our pavement surface condition index application that takes an input as that takes the input images and classify them on a rating scale of 1 to 10. In the first screen that you see when you will connect your browser to the server would be the screen which first checks whether you have set the model checkpoint, and then for the segmentation extraction, the model checkpoint for the image classification, and you have also read the help file, and you have also set the HTTP server uh, that is running separately to download all the result files or the output files. Once you do that, then there is an other selection option where you can select which part do you want to go. Let's go first on the help side. So here, these are the few instructions to use the software. Then we move on. The first target would be to analyze the images. And then once we have analyzed the images, it will generate a CSV file that will be used to analyze the data. And then after analyzing the data, we can visualize it on a map, on a 2D map. Let's start with the image analysis. Here we can go and choose a folder from our local drive for the image analysis. Make sure that it has been zipped and it's less than 200 MB. So we have created a folder here, which is loop 1A images, which you can select. The size is less than 200 MB. There are approximately 1,291 images in this folder. So it'll take a while to download it on the server and unzip it. Once it is unzipped, it will ask you whether you would like to start the pavement extraction or not. So here you can choose what type of analysis you would like to do. The first is the pavement extraction. Then we can do the rating. And then once we have the ratings, we can also do the stress analysis. First, let's keep on the pavement surface extraction and start this process. So once this process starts, although there are a lot of images, I will not go through all of them. So the process have started of pavement extraction. So once the images have been the pixel have been extracted, the results can be seen here. This threshold value is there just to enable the user, if he would like to, for example, in case where the segmentation results are not that good. So this is the value that if the user would like to select a particular image which have less number of extracted pixels as compared to the whole area of the image. So for for as a default value, we set this value to be as 0.1. And then once the pavement pixel has been extracted, You can see two folders here, which you can download. So we can download the crop images, and we can also download the segmented images. And if you would like to see, for example, a particular result of a particular image, you can select the image from here, and it will show you the result of that particular image. And you can keep on going to any image result that you would like to see. And once you are satisfied with the segmentation results, you can right click or double click it to save it on to your local device. For example, here I would like to save this one. So I have already saved it earlier. I can save it again with another name, and this would be saved. Similarly, you can also download the segmented images and save it. So now the next task would be to go on with the image classification, image pavement rating. We'll click that. A new screen, a new page is in front of me, where you can again select the images that you saved in the previous page. And now you can upload them back again. I can upload this one, or I can upload this one. So you can upload the images from the previous step. And once they are being uploaded, the application would ask you whether to start the pavement classification. And if you like to see the results can be seen here. Currently, there are no results in the temporary folder. So it will show you that none of the images has been processed. We can start the automated pavement condition surface rating, and it will take a while to do that. Normally, we see that it is running at a frame rate of 10 frames per second, which is quite a decent computational time. Once all the images are being classified, the results can be able to visualize at the bottom. Here you can select different images, different index of the images to see the result. For example, the 12th image is of the rating 4. So along with the image, so the color green shows that this is in the rating band of green. 9 and 10, as I told you earlier, it's in the green band. Along with that, we get the probability of this row to be 9, and this is the actual rating. If we go further down, for example, this is a rating of 5, and then let's say this is a rating 5 again with a probability of 91%. And this shows the prediction over time. Because there are a lot of images, we could not see it in a more detail. We can expand it, or we can take it back to the original position. But then at the end of this classification or the pavement rating, we we are able to now save the results in a CSV file. So we would like to save it. So once the results are being saved in a CSV file, it should be able to download. We will right click it or double click it to save the file. And this file would be saved in our computer. We would like to save it here. And once the results are saved, you like to replace the previous file, or we can replace it with a new name. Another step is the distress analysis. This is an option that you can use to see which part of the pavement is used for to class an image on to a particular rating scale. For example, if we choose any image, for example, this one, and apply a method, here we are applying grad cam. So the grad cam is showing us the part of the image, or the pavement pixels that are being considered to rate this image on a per, uh, uh, to rate this image on a rating scale of 1 to 10. So after this step, we have the CSV file saved in our computer. Now we will go on with the next step. The next step would be to analyze or to see the data itself, the CSV file. So we'll move on with the CSV data analysis tool. Here you will see on this side different threshold values, the probability threshold you would like to choose to use an image probability for the rating scale. And then this is the filtering window, the moving average filtering window. And then this is uh, the number of images that are used for the most common ratings. And there are different type of filters that are being supported by this software: moving average, exponential moving average, Gaussian filter, and median filter. And along with that, we have also two types of images. For example, and we would like to see the image index or the distance in kilometers. Now, we have generated an image CSV file that we will choose. We saved it here. We can choose the CSV file here, and it will show us the results. So here you can see the image index and its particular rating along the image index. So this type of visualization is helpful for the data analyst to see uh, how does the road that is being captured would look like on a section basis. For example, here we are using 20 images as a section. So each of the 20 images would be given a particular rating based on the most common rating in that particular section. And before applying this most common rating, we have also applied a moving average filter on a window of 5 or on 5 subsequent images. So we can increase this number here. For example, we can make it 20. 20 is the minimum, usually the minimum size that size which basically consists of 20 images, and it basically covers an area of 100 meters, while 40 images would be then means that it's an area of 200 meters. So usually the raters give a rating to at least 100 or 200 meters of a section. So here we can see the section, a 200-meter of section is being given the most common rating. And before applying the most common rating, we have applied a moving averaging filter here. So once the rater has been satisfied with the result, uh, he can save the results. So this is the moving averaging filter, and along with that, the most common rating. And here you can see the idea is to analyze it in a better way as compared to image analysis. So this is called as section rating. So the section ratings can be saved in the form of a summary, or it can be saved as a full rating. For now, we will save it in a full rating first. And if we save the data is ready to download, and the data would be saved here. Similarly, we can also save the data in a summary form. So the difference between the two is that in the summary form, let me show you. So in the summary form, the result would be in the CSV file with the most common ratings. So here you can see the most common ratings, the start of the image and the end of the image, which have the same ratings. And this is being saved in a sequential form. So once this is saved, now the next option for the data analyst would be to visualize the results. So we'll go back and now select map visualization. In the map visualization, the important thing is to first get the GPS file that is being captured during the data capturing or image capturing process. So we'll give that file to the software. So this is the loop1a GPS file, which contains the GPS location along with the distance measurement of each file. Once this is given, the next file that this software would require is the file that we have generated from the previous step, and that is the output data file. Once it is selected, then it will show you the result on a map, and along with that, it will also show you the image index with the chain. Chain means how much kilometer has been, or the distance, how much distance from the first image has been passed in this next image. And this is the approximate lat and long. And this is the rating. The data analyst can go along and see the lat long and the rating that is given to each image and the at a particular lat long. And you can also visualize the section ratings graph, and along with that, the map that shows you the rating. So here, this is a rating from 5 to 6. This is a rating from 7 to 8. And we can see that there is no green patch in it. So once this is done, you can go back again and repeat the step with the new images. So that is all for now.